Okay, so what we're trying to accomplish in this video is we're taking a look at how you could write the polynomial or a possible polynomial if you know the zeros of the function. So what I'm saying in this first statement here is if somebody gives you the zeros and says write the polynomial that could produce these zeros, okay, what we're going to do is we're going to turn those zeros back into factors, and then we're going to multiply all the factors together, and that is a possible expression. Okay, and as we get a little bit more detailed, we'll be a little bit more specific about the expression. But what we know for sure is that in our first example here, if x equals 4 is a 0, then there was a polynomial factor that gave us that x equals 4. Okay? And the simplest one that we could do is if I started off with x equals 4, if I'm calling this a 0, I'm basically saying that the factor that gave us this answer was set equal to 0. So that's what I'm going to do. I'm going to subtract this 4 over to the left, and by doing that, I'm going to set it equal to 0. This is going to become x minus 4 equals 0. And I can do that for each of my zeros, right? If I had x equals 2, if I subtract that over to the left, okay, that's going to be x minus 2 equals 0. Okay, and then if I have x equals negative 5 as a 0, if I add over the 5, okay, which I'll call this 5, okay, if I add over negative 5, it's going to become x plus 5 equals 0. Right? So if you notice, now I have the three factors that produced each of the zeros that they gave me. And so what I'm going to be able to do is say the expression that I started with in standard form would be just taking x minus 4, x minus 2, and x plus 5, and multiplying this back together. And so you might be asking yourself, well, how do I multiply together three polynomials, or three binomials in this case? Right? Well, if I were to go to a simple problem like 3 times 5 times 2, and I ask you how you multiply those together, well, what you really do is you just pick any two of them, multiply them together and get that answer, and then multiply it by the third one. So for example, in this problem, I would say 3 times 5 is 15 times 2, and then 15 times 2 is 30. Okay, so I do it one at a time. So I'm going to do the same thing over here. I'm going to multiply together two of these binomials just using FOIL, right? And then I'm going to simplify that answer and then multiply the third one in. Okay, so I'm going to let you do all of the middle steps here. If you multiply together x minus 4 times x minus 2, the answer is x squared minus 6x plus 8. Okay, and that is just the first two expressions multiplied together, right? And then the x plus 5 I'm just going to bring down. Okay. And so then I have this problem right here where I'm going to have to multiply all this out, which multiplying a trinomial times a binomial is just multiplying everything with everything. So x squared times x is x cubed. Okay? X squared times 5 is 5x squared. Negative 6 times x is negative 6x squared. Negative 6 times 5 is negative 30x. 8 times x is 8x. Okay? And 8 times 5 is positive 40. Okay? So if I now go through and just simplify this, I have my answer. So I have x cubed. I could put together 5x squared minus 6x squared and get negative 1x squared. Right? I could put together negative 30x and 8x and get a negative 22x plus 40. Okay? So to answer their question in standard form just meaning highest exponent first counting down, this expression right here is this a possible polynomial that could produce those zeros. And the only way that this could be different, and we would need some more information, we might need to know, for example, that the ends of this graph were, because it's an odd polynomial, if they were up down, I know that my lead coefficient might have to be negative, and I might have to multiply everything by negative 1 or something like that. Maybe I double everything or triple everything, but this is the most basic equation in standard form that could produce x equals 2, x equals 4, and x equals negative 5. Okay, so it's just a matter of turning all of the factors into, turning all the zeros into factors, multiplying all of them together. Okay, so let's take a look at another example. So if I had x equals 0, x equals 2/3, and x equals 1, same basic process, right? Here's the catch, though. X equals 0 is done. I don't have to do anything with that. It's already set equal to 0, which means x is a factor. Okay, so we'll see that in a second. If x equals 2/3, okay, how I'm going to handle this one, you do it a couple of different ways. Okay, I can multiply the 3 over, which make it 3x equals 2, and then I could subtract the 2 over 3x minus 2 equals 0, right? And that's an answer now. Okay, if the last one, x equals 1, that's pretty straightforward. I'm going to subtract the 1 over, and I'll get x minus 1 equals 0. So in this case, here are my factors. X, 3x minus 2, and x minus 1. So again, you have the decision to make about how you want to multiply these together. I'm going to choose to multiply together the second two first while they're still pretty simple looking. And this problem gives me, again, I'll let you do all the work, 3x squared. I get negative 2x and negative 3x to make a negative 5x plus 2. Right, and then the x is still just sitting out there, and then I can just distribute the x in, and it becomes 3x cubed, okay, minus 5x squared plus 2x. And that would be, in standard form, a polynomial that could represent, could produce the zeros x equals 0, x equals 2/3, x equals 1. Okay, so if you take a look, I have two try problems here. The first one is very similar to the ones that we did. I'll let you try that out on your own. Okay, if you want to take a look at the second one, there's a little bit of an extra piece of information that we want to try out. So I'm giving the second one. I'm going to do this one with you now. Okay, so the same basic idea, and again, I'll let you go through and try it out and see what happens. But what we're going to get here is, again, x equals 0, okay, x minus 3 equals 0. Okay, and again, this 4/3, I'm going to multiply the 3 over, which would make it 3x, and then I'm going to subtract the 4, so it becomes 3x minus 4 equals 0. Okay, so let's multiply these together. Same basic idea. X minus 3, and 3x minus 4. So again, I'm going to multiply the second two together. It becomes 3x squared, okay, and I get negative 9x and negative 4x. That sounds like negative 13x, okay, plus 12. Okay, all with an x. And then I'm going to distribute that x in, so it becomes 3x squared minus 13x, okay, and a plus 12. I'm sorry, plus 12. This is 13x squared. This is an x cubed, okay, and that's plus 12x, okay? So I distributed the 3 in. But here's the extra catch with this one. I asked also that for it to have up-down end behavior. And what up-down end behavior is, remember, it means is that when I graph it, it's going to be up on the left, okay, and it's going to be down on the right, and it's going to look something like this. My particular polynomial doesn't fit that description because it's got a positive lead coefficient of 3, which means I'm going to have a down-up. Right, so in order to fix that, I'm going to have to multiply everything by negative 1. Okay, so I'm going to say negative 3x squared plus negative 3x cubed plus 13x squared, okay, minus 12. Right, and so this will fix our problem. Now I have a negative lead coefficient, which would mean that I have an up-down end behavior.